Hello, everyone. So welcome to my session on a survey of GNU-GAL software. My name is Eric Adrosa, and a little bit about me. I discovered GNU-GAL about late 2014 and have been using it ever since. I'm a maintainer of two packages, GAL CommonMark, which is a specified version of Markdown, and GALGit, which is bindings to libgit 2. I'm also professionally, I'm a C++ software developer from Miami, Florida. So what is GNU-GAL? GNU-GAL stands for the GNU Ubiquitous Intelligent Language for Extensions. It's the official extension language of the GNU project, and it's implementation of scheme programming language. So a little bit about the origins of GNU-GAL. So inspired by the customizability and extendability of GNU Emacs, GNU hackers want to bring this to the rest of GNU. If you can imagine how much you can extend with Emacs, if you could extend to any software in the GNU ecosystem. And they decided to use Scheme because it was simple and clean over perhaps Emacs Lisp. But they still wanted to support other languages like Emacs Lisp and TCL. You can actually read more about the history of GNU-GAL in the manual for GNU-GAL. It provides really interesting background of what was the purpose of creating GAL. So let's get some definitions. So what I mean by custom, it means that the software is it's easy to alter the behavior of the software. And then when it's extensible, you can go beyond simply simple customizations and create new ways to use the software. And before we go on to talk more about GNU-GAL, let's talk about GNU Emacs, which kind of inspired the whole creation of GNU-GAL. It's an extensible, customizable, free and libre text editor. It's also a calendar, an email client, a package manager, a web browser, and even more, as users keep using and extending and sharing GNU Emacs extensions, and is easily available for everyone to use. So how does Emacs allow users to extend the software? One of the basic features is this whole concept of a command. With the command loop, it's similar to an idea to a read eval print loop common in interpreted languages, where instead of where you first read a key sequence of keyboard input, and that gets translated to a command, and then that command gets executed. Of course, there's a lot more stuff going on, but that's just a simple idea. And here I have presented an example of a command, hello, which takes in a name. And the most important part is this interactive part, interactive expression, which takes in the string which S denotes that this, when this command is executed, it takes in a string, and it prompts the user for a name in the mini buffer. And then after you execute the command, it will then execute the body, which is just to print hello with the name in the mini buffer. So let's see what this looks like. So here we have the actual code, and then we evaluate this buffer. And then using mx hello, I execute this command. And it prompts the name, and I enter my name, Eric. And then it will just say, hello, Eric. You could just sort of imagine how complex, what more can you do with these commands? You can have like a series of commands to create new extensions. And then how to customize Emacs. So a lot of these extensions also provide ways to customize the behavior of the software. And these are also often called customizable variables or user options. You could do simple customizations with the customize command, which is a sort of user interface for customizing the behavior. And Emacs will also prompt you to save these files so you could persist per sessions. Or, which probably is more common, is that users actually edit their init file, which gets loaded when Emacs starts. And an example here is this tab width, which we set it to 4. And then Emacs also provides a way for these extensions to add their own def customs and with their own customized variable with def custom. And these could be then also viewable in the customize command user interface. So one also important thing about GNU about GNU Emacs is that it's self-documenting. This is like one of my favorite features, is that you could actually go, there's tons of commands that could help you understand what the software is doing and how it works. So in this example, using describe variable, you can give a variable name and it'll point to the documentation for that variable, as well as tell you maybe initial value, where to find this in the source code, and additional details. There's other commands, help commands like describe function, describe mode, and plenty others to explore. So now let's actually get to some software that uses GNU GAO. And the first one is GNU Guix. GNU Guix is a package management tool that uses this sort of functional approach to help create reproducible builds. It uses a declarative approach to define packages, as well as a configuration to configure operating systems. So here's an example of a Guix package, where it's for the GNU Hello package. And it's a basic example of a GNU package. And as you can see here, there's a sort of like a DSL with this package, where you could give the name, the version, where to find the actual source code for this, and as well as tell it to what system, how to build it. So as an example, it uses the GNU build system, and a little bit of description. As you can see here, you can see actually some scheme code is actually part of this DSL, where it's, for the URL part, it actually uses string append, where it can actually access the version. So when you make a modification to a new version, you don't have to then edit the string. You just use string append with that version, and it automatically do it for you. This DSL can also do other things. So as well as this example, where for GAO 2.0, we find this package called GAO 2.0 common mark, where it inherits from the original GAO common mark package. And this package uses GAO 2.2, and this provides a version to use the 2.0 version. And just simple here is just inherit from this parent package, and you get all the details from that package, and then just make the change that you want. So here we just change the name and the input to use GAO 2.0. And here's an example of actual Guix operating system configuration. Here it uses a similar approach for using a DSL for declaring the operating system, and as well you could just use normal scheme code to interact with this. As you can see, there's list, append, cons. It's all scheme. And then with this operating system, you could then use Guix to actually build and install this onto your laptop or desktop, as well as create virtual machines based on this configuration. What about also extending Guix? You could extend it with Scheme. Here's an example of, since Guix is written in Scheme, a lot of the functionality is available through the API. So in this example, we just import the Guix packages to get the package inputs procedure, as well as get all the packages from the package management module. And here we just get Guix, and we want to get a list of all the inputs. And since it's then we use mapcar to get the names of all the packages that's used to build Guix. So next project is GNU Cash. It's a personal and small business accounting software. It uses double entry accounting. And for those unfamiliar with it, I recommend checking out GNU Cash's documentation, where it actually explains a lot of this. And it uses GAO to allow users to create custom reports. So let's look at what these sort of reports look like. So there's a define report, where we give it a bunch of arguments which give you the version, the name, and various other things for this report. As you can see, it's sort of how the argument is that first is a symbol, which is for the argument, and then the value. This is sort of almost like a property list from Lisp. The most important part is the options generator and the renderer. This is actually what would be used to then configure your report and then render that what it displays on the screen. So let's look at the options generator. So the options generator creates a new option, and then with this, it allows you to register a bunch of options. In this example, we create a simple Boolean option, and we put it on the section 1. That's basically where in GNU Cache, so when you go to the options, it actually has a bunch of pages where you could put your different options. And then we give it a name, options name, help text. There's also the sorting key, which determines where it's placed in the option menu. And then we also give a default value here. It's true. And then we set it to have the default section to be section 1, and we just return the options. And something you might notice, which is kind of weird, is the capital N underscore. That's just used for if you want to provide translations for your reports. So it will translate these strings. And let's look at the document renderer. So the document renderer will take in a report and then allows you to create then an HTML document, and we could access the options for this report. And here we get that Boolean option we defined in the previous slide and get the value. And then we do some manipulation of the document. We set the title, and then we can add objects to the document. So here we just add a paragraph, a P tag, and based on the value of that option, we print if its option was true or option was false. And then we just return the document. And you can see, it allows users to create a lot of various documents with full features available to Guile. So let's look at another project. Next project is GNU LilyPond. So it's a music engraving program. It uses a text-based notation for music input. It's similar to using LaTeX, if you're familiar with that. Here's an example of what the input language looks like. The slash is what helps what's a command. So /version tells that this input language is only for this version of LilyPond. And then the next example shows a variable assignment, where we're assigning this relative from the notes C, D, E, F, the sequence, and we assign it to this variable foo. And then if we want to print it out, we do /foo. And then that's what prints out this document that we have here, this notation. So what this actually looks like, there's actually a LilyPond internal representation in Scheme. So as you can see here, that relative music, it creates this make music, relative octave music. That was that relative, that \relative. And then we make we have a sequential bunch of notes. And those were the notes that were in the previous. So what about the scheme? Where's the scheme? So you can actually put inline scheme into LilyPond. So here's an example of we take that previous foo variable, where we define this procedure called twice, where it creates a sequential music where we just repeat the same, whatever input was given, and then we could access these variables in Scheme as well. So here we call twice foo, that accesses that foo variable that we defined above, and we assign it to bar, and then we just print it out, and that's what it looks like above. It just repeats it twice. So I showed you a lot of the customization from previous software, but what else can we do? What else does Guile could support? So one of the features was that it could support multiple languages. For example, there's WISP, which is an indented space syntax that translates into S expression. So if you're not so happy with the whole parentheses, there's WISP. And it's often described as similar to Python. There's also Lua, which using this package called Guile Lua. There's DeemD, which is actually a language that extends Scheme with static typing. There's ECMAScript, which is more of an experimental implementation in Guile, but a lot more effort can be used to make it more production ready. But ECMAScript is also known as JavaScript, if you're not familiar. And then also recently is that it has full support for Emacs Lisp, which GNU Emacs uses. So I think it would be interesting to use these more for your extensions. And though there's some, I think, issues that we might encounter. So if you have an extension that relies on a lot of DSLs, it might not be available because you're using like the scheme macros. It might not be available in other languages, like Lua or ECMAScript. And there's also, if these languages also define their own data structures, how do we allow users to extend when you're using multiple different languages? I think it's a very interesting area to explore. And also, what about if we take more inspiration from Emacs commands? Can we bring this editor command loop from Emacs to other software? There's actually been an attempt called Emacsy that allows, it's an embeddable Emacs-like library for Gal that allows you to add a command loop to your software. And I think if you want, it would be probably a good idea to revive this project if you want to still consider this idea for extending our software. And also self-documenting software. I think this is one of my favorite features. It's what helps you understand what the software is doing. You could use it to help you extend, help you, provide a lot of documentation. How should this help documentation be displayed in our programs? It's kind of unsure. Should it be like Emacs where like a buffer pops up, or should it be like a separate window, or how else should we provide this sort of documentation? And then like what else can we do? Can we continue to get inspiration from Emacs? Can we maybe come up with something new? I think this is something that we as a community should look into more. So that's it. Join us. We have a community free node on Guile. You can learn more about GNU Guile at the website there. Thank you. Any questions?
I was recently choosing the extension language to put on a piece of liberated free software, and my first thought was, well, Guile, of course. But then I looked at Chibi Scheme, and I thought, oh, I like this much better. What do you think?
I mean, it's your personal choice, what you want to use for an extension language.
Yeah, I think at some point Guile will evolve up to the R7 level that Chibi has.
Yeah, like I know, Guile has improved a lot from what I understand. It used to be not that popular, and then with like Geeks, it's been gaining popularity again. And there's been a lot of development has been going into Guile, it's been gaining a lot of performance improvements. And hopefully 3.0 is going to actually improve the speed even more.
Is Guile only an extension language, or can you run it on its own? And if so, what kind of standard libraries does it have access to?
So yeah, it's its own programming language. Like for example, Geeks is entirely written in Guile, so you can use it to write your entire program in. It has its own library, and it's not as big as probably like Python but though so there's a lot of interest trying to improve the library support, the library ecosystem for Guile.
Yeah, so I saw like the get URL, for example, and you can open files and do SHA-SUMs and stuff like that. Like that sort of thing is already in that library.
Well, some of that's probably part of Geeks.
Okay.
Though I know there's been some efforts to like move out some of the parts from Geeks into like its own separate library. It's like, for example, GuileGit was almost part of Geeks, but then we split out to its own library.
Thank you.
No problem.